And we are live. This is cool. First quantum economy talk. Thank you for tuning in. My name is Anders Inset. And before we get into our first episode, I just want to give you a little bit of context of what we're doing and what the quantum economy is all about. So, we are setting up a Quantum Economy Institute that will do research and publishing on the future of the economy. And we've divided that into four centers. One center covers the products and the services of the future. It's called the quantum goods and services. We look at business models and potentialities of technologies to solve some of the challenges that we have in our society today. The second center is evolved around quantum economics, looking at decentralized finance, centralized finance, looking at digital currencies and security around the cryptographies and the challenges that exponential technologies bring. The third center evolved around the future of leadership and organizational structures. It's what we call the infinite leader and how we look at leadership in the light of the 21st century, where we move from management and command and control into creating new paradigms and new structures in a world where we have to tackle the challenges ahead of us with leaders of change. The fourth center is more futuristic. It's what we call the quantum human. It's about how we bridge the gap between AI or quantum AI with humanity. And this institute will evolve around publications, research, and be centered in Germany. But today we're talking about what got it all started, simulation hypothesis. And before we get into the question of whether this is real or not, I just want to give you a short background how it all happened. So about a year ago, in June 2022, I was in Vienna. We visited a partner company, Terra Quantum, that I'm involved with. And there were 12, 13, 14 physicists that were out night partying in Vienna, basically sitting around talking about existential questions and challenges, both on the scientific side and also on the philosophical side. And my today good friend that I've spent the last months and the year and a half publishing and having all these discussions on long night calls, Florian Neukert, was there. And I asked him, Florian, can you prove to me that we are not living in a simulation? And the background of Florian is in this field is really deep. He has led the quantum computing, quantum technology initiatives at Volkswagen, and today is on the board of Terra Quantum, and he has published a lot in this field. But Florian called me about 3 months later and said, Anders, I haven't slept in 3 months. There is something to this question. So we teamed up with the founder of Terra Quantum, Markus Flitsch, and Michael Perstein, who is also with Terra Quantum, and we wrote a paper titled The God Experiment, where we looked into this hypothesis. And without further ado, I know it's early in the valley, Florian, but let's get this first quantum economy talk episode started with the question that got us all going on this topic. Are we living in a simulation?
Absolutely. That's a tough question. So, and I remember very well when we first talked about it. And I also remember what I first said. I said, when you asked me about whether we live in a simulation and to prove that we don't, I said, well, that's easy. I just send you a couple bullet points via email. And that's how everything started. And it was not a couple bullet points. It was very hard to prove or disprove. So the simulation hypothesis has gained a lot of popularity, I'd say. So there are many influential people talking about it and having opinions on it. However, these opinions are very often limited to it's true or it's nonsense. So people don't wonder and worry about what it takes to prove whether we live in a simulation or not. And I know the question, when you hear it for the first time, it sounds like a sort of strange question. It's almost a little into mysticism, but it's not. So it's a legit scientific question. So, and what is the simulation hypothesis in general? It's a theoretical concept, and that just says our universe might be a computer simulation by an external entity. And the problem with that simulation hypothesis is that currently we don't have any direct evidence supporting it or refuting it. So that's why we think, and that's why we wrote that paper, it is important to think about experiments, think about things that we can observe in our current universe that would give us indication as to whether we would live in a simulation or not, and to prove it or to refute this hypothesis. So we need to design this indirect test to verify or refute it. So in short, we proposed a list of experiments. So one being, let's say we create our own simulation and see if in that simulation, a simulation chain evolves. We look at the universe and try to find physical evidence as to how the universe in certain areas might reduce complexity. So not by itself, but by an external programmer who theoretically might have, in our view, infinite powers. So we want to find hints, we want to find indications that give us some idea as to whether it's true or not. And in the course of this research, we identified a couple of constraints. So it's very interesting when you think about simulating the universe. At first, you might think, well, not a problem at all. If I had a computer that's powerful enough, I'd just do it. But we found out there are a couple of constraints. So we found 6 of them. That doesn't mean that these are all constraints. And these go into what's computable in the universe at all. So is it even possible? So if I look at our universe, for example, with all the particles and fields, would it even be possible to simulate the whole thing? And it turns out it's not. So it's very difficult. I could not simulate the universe as is, but I could maybe simulate a universe, a smaller part of it, and see what happens in there. And then there is quantum physics. So it's not only about the size and the constraints that we see with computers, so theoretically, it's also about the most fundamental physics in the universe. So this most fundamental physics prevents us to make predictions that are very, very, or exact. So it's probabilistic always. So the challenge here is that even if I were to build a computer that could simulate the whole universe in its current state, and I were able to make some predictions about future states, then the problem would still be with quantum physics. So it's probabilistic, so it's very hard to exactly simulate, and exact predictions are statistically impossible. So it's hard. So that is another problem. However, in this paper, we do not aim for a final solution. We encourage the discussion. So the idea would really be, we throw these constraints out, we have others think about it, we have others think about the simulation hypothesis and how it would impact us, how it would impact our life. So what would it mean if we find out we are all simulated beings? Does that change our very notion of what life means, what life is, or doesn't it matter at all? And for that, I mean, I think we should discuss first what we mean when we say something is real, Anders. So what does it mean?
Yeah, I mean, maybe we'll track back a little bit, because this is obviously not a new question. So, I mean, you can talk about it in the lights of Plato's cave and the shadows of the wall. René Descartes, who had that evil demon that was feeding him with sensation, and he fought, trying to argue against it. You have the notion of illusionism that philosopher Dave Dennett has been very pro and talking about, that, you know, our sensations, our experiences, our qualia is an illusion. And then you have the idealism that was proposed back in the 18th century from Bishop Berkeley, or philosopher George Berkeley, that basically states that, you know, what you perceive is real. And that is, you know, what gets us thinking when we all of us take this question to the coffee tables around the world. Everyone probably got, you know, interested in the topic more seriously when they watched The Matrix, the 1999, I think, good visualization of the red and blue pill scenario. And 2003, Nick Bostrom, the Swedish philosopher, proposed this simulation hypothesis. And we will put the link to the paper in the comment field and add some additional links for a deep dive. But just a short introduction to that theory or hypothesis, if not everyone is aware of where this comes from. So in 2003, Bostrom proposed that there are 3 scenarios to look at this. One is humanity dies. There's like an end state where humanity gets extinct before we build the simulation. That's one scenario. The second scenario is basically the scenario that we get tired of progress. So That's like visualization in a simple term. My iPhone now has enough. We have enough technology. Let's focus on other things. That's a second scenario. And the third scenario is that with progress, eventually we could simulate the universe. We could build a quantum computer that of size that could render out parts or build that simulation. And if that is possible, it follows that the likelihood that it has already happened is much higher than that it hasn't. And this is why Elon Musk has said there is a 1 in a billion chance that we're not living in a simulation. So he is convinced we're living in a simulation. Even cosmologist, pop cosmologist Neil deGrasse Tyson thinks there's a high likelihood that this all is a simulation. So it's a very interesting question, and I've been thinking about this like you, Florian, for many years now. And I think if you put on those goggles in a virtual world, you perceive this world. So you can't argue against the perception. So when you perceive the world, and this is also basically the thought about subjective idealism, you cannot argue against my experience that it feels like something looking into a camera talking with you in San Francisco right now. And that's the experience of your own experience. And it's very difficult to argue against that. Don Hoffman said that consciousness is an illusion, but it feels like it's real. But then again, if we could simulate the exact same experience, then basically we could say that it doesn't really matter if you have the goggles on or not. It's just that what we perceive is real, and it feels like it's real. But I think if we look at this history of things, I would be very interested to know, can we kind of sort of find glitches in a simulation? If everyone is like out there postulating there's a high likelihood, could we find glitches? A computer game is often built with like hints and things that you can find that are cracks or I would say like not finalized concept of the simulation. And the second question would be, are there things that limit us from building simulation? So the particles in the universe, are there concepts in physics that would limit us to eventually build a computer? And maybe you can touch upon that, because I think that's something that's also very interesting to think about. What are the limitations of such a computer?
Absolutely. Yeah, that's all very, very deep and exciting questions. Maybe we should start with the limitations of what's computable. I mean, there is quantum physics. We all heard about it. There was the first quantum revolution, which gave us the transistors, or the first quantum revolution, meaning people observed quantum effects on a large scale on many particles that acted the same way. So lasers is a technology of the first quantum revolution, but also the transistor. So, and the transistor gave us the digital computer. And in my view, the digital computer is one of the most remarkable inventions that humankind has ever come up with. It's very hard to think about what would not have happened if we didn't have the computer. So it's I feel one of those things that really changed the course of history for humankind. And now we are in the second quantum revolution, where we are able to control single quantum objects. We can control the spin of an electron, for example, and use that to represent information, quantum information, a quantum bit, the smallest unit of information in what's called a quantum computer. So the second quantum revolution also gives us a computer, a different kind of computer, one that will have the ability to simulate nature as is. So that was also something that Richard Feynman and other physicists prominently brought forward in the 80s and later, and also sometimes earlier, when they said, if you want to simulate nature, it must be quantum physical, which is true. So when we look at the smallest scale, when we look at atomic and subatomic.
Can I pause you there? Why is that true? I mean, why is it true that it must be quantum physical? So I mean, I understand that quantum physics is the most fundamental understanding of reality that we have, but we have not yet agreed upon. I mean, even within Terra Quantum, there are different views, and your team colleagues, you build stuff. I mean, you build real stuff for reality, but you don't necessarily agree on the foundations, what quantum physics is telling us. So why is that a true statement?
So what quantum physics is telling us, I think that's a question very often for philosophers like you. So in the end, and I don't want to be ignorant here, but in the end, what we do in physics, what happens in physics is that we make experiments, we make observations, and we find models that describe these experiments and observations. So we do that many, many times on different scales. And if that were true on all different scales, so this model, then we formulate a theory. And once we have that theory, then we can do things with that theory. We can, of course, test the theory, but we can also build technology on that. So there are different interpretations of quantum physics. That is very much true. So, for example, a question that you might ask is, there is this very prominent example that physical reality does not exist until I measure. So you have heard of superpositions or quantum systems. I take a very simple one, an electron, and I look at the spin, which only has two configurations, spin up and spin down. As long as I don't look, it is in both of these configurations at once. So it's not in a certain configuration, in one specific configuration. And that implies that as long as I don't look, in that case, would mean firing polarized laser light at it. If I don't look, it exists in all possible configurations, and one specific physical reality does not exist. So it only exists when I look, when I measure that system.
You need a measuring apparatus. It could be a conscious human being or some kind of measurement apparatus that kind of sort of gets into the JIT of reality. So you go away from the abstraction into the concrete. So you go from the idea, the concept of something existing into physicalism and say, this is where I manifest, this is the collapse of the wave function, and this is where something becomes something, right?
Yes, absolutely. And then there are, of course, other ways to interpret that. I mean, there is Hugh Everett's many worlds interpretation, which just says that anytime a quantum event happened and this superposition of states collapses into one definite state, it doesn't really collapse. It just means all the other configurations branch off in different worlds. So that is a mathematical model, physically very hard to prove because we do not see these other worlds, but mathematically sound and would explain that. And so that's interesting questions to ask. So what does it mean now that we understand some things about quantum physics? What does that mean for reality? And so when does this transition happen exactly? So from these many states and many possible ways of potential outcomes, when does it change to what we actually see and perceive here? Because my computer, for example, or my coffee cup here, that only exists in this one specific configuration that I see here. There's all interesting questions to ask and highlight, of course, yeah. And there are different things on it.
Yeah. But isn't it so that the many worlds interpretation of Everett is kind of like the same dilemma that you have with simulation? So let's say you could simulate a universe, all the particles in the universe, and you can leave out some spaces. And like a computer game, you would only render what you observe, right? So everything would be very downscaled, less energy, and you would just observe various positions. But if you then have like millions of simulations, simulation in a simulation, and you have like a 14-year-old boy playing around the game that we are playing, throwing in some physical laws and letting us play around in that game, we would then continue to simulate ad infinitum. Isn't it the same that it applies some underlying rules? Isn't there some energetic? You can really talk a little bit about entropy and the findings and the thoughts that we had around, exhausting the simulation, and also and I think that would apply also for the many worlds interpretation, right?
So depends on how an external programmer would run that simulation. If they were to run all the worlds, then yeah, of course. But even for a single world, it already applies. So you bring up a couple of interesting points. Mm-hmm. So if we try to simulate a universe exactly, so that's the recursion problem. So one of the constraints we found, then if we were to simulate our universe, for example, then what we also have to do is simulate the computer in that universe that simulates that universe. So, and there are a couple of constraints. So for example, if I want to make a prediction, so ideally I want to run the simulation faster and see what happens at the end, so to say. If I tell the computer, predict what's happening at time 1, and then at time 0.5, I tell it, well, now predict what's happening at time 2, then before it reaches 1, it would already change its internal state to predict 2, and once it reaches 1, the original prediction would be wrong. So there are also logical flaws that we have here. The other problem with simulating is and as we look at the universe, as it expands, as we currently understand, as objects in the universe form and then at some point degrade again. So we would assume that the complexity in the universe goes down. So it will become less complex over time. Entropy increases. So that means even the planets, the stars, as we know, at some point they will fade away. They will fade away, and you will only have single atoms remaining. And then at some point the atoms will also degrade. So, and then not much is left. But still, if we look at the increasing entropy and the interactions that all these particles have, with quantum effects coming into play, entangled particles, the actual complexity increases. So even though on a macroscopic scale we lose galaxies, we lose clusters, we lose stars and planets, the complexity of simulating the universe is computationally increasing. So what does that mean? At some point, no matter how powerful that external computer is, that an external entity may use to simulate the universe, the computational resources will be exhausted. Even worse, if we think about being in a simulation, then it is very likely that we are not the first simulation. So it's very likely that we are in a chain of simulations. And that's the next interesting aspect. So anytime we have a simulation, and in this simulation, an intelligent species emerges that creates a simulation and so forth, they will have only the computational power available from the top level. So if we go deeper and deeper and deeper, at some point, all simulations will come to a halt because computational power is running out, except an external programmer intervenes and reduces complexity. So a completely crazy concept would be a reversal of entropy in the universe. So if we were to observe that at some point, somewhere, then that could be an indication that we live in a simulation, because an external programmer would have the ability to do that, while of course we in our universe cannot just reverse entropy.
Yeah. How would you notice that? I mean, how could you find the glitch? How can you see that someone would be flipping around with entropy and just reducing entropy or reversing you? And I know there was some writing a couple of weeks ago about some thoughts, reflections on this, and maybe to add to that question, what I'm curious about, what do you think is like the reason why prominent figures like Musk and also Neil deGrasse Tyson go out with an absolute statement or a very high probability? Various scientists completely debunk it. Like I think Sabine Hossenfelder is very critical about some of these things, say this is pseudoscience, and is not open to looking into this aspect. So my first question would be like basically around the reflection on how to notice the entropy and reversal of entropy or mixing up that anthropological structure. And the second is how it's related to how do you think that the opinions vary so much?
Mm-hmm. So in terms of the entropy reversal, I think it would be in some sense very simple. So we know what happens to stars, for example, when they exhaust their nuclear fuel, when they at some point go supernova. So if that would be a very extreme example, see a reversal of that process, that could be an indication. But of course, there are much more simple systems, much more simple things that we could observe. So
you mean a star basically going from collapse back to structure? It's like
yes, okay, that would be a very extreme example. Yes.
Yeah, unscrambling eggs. So you scramble the eggs back to the egg. Yeah, I mean that's okay. That's the scenario that people I think can relate to, right? Once you have unscrambled an egg, it's a complexity and how you bring that back to the egg, right? That's basically what you're talking about.
Yes. Yeah. So but there are much more simple systems that we can observe, and experiments that we could potentially do. But that would be an example, and the egg example is particularly good. I like that too. Yes.
You would avoid the egg and the whole notion of the complexity of the egg if you could just scramble it and unscramble it, and you can see that. I think that's where you would have an evidence that you can mix a little bit with reality, right?
Absolutely, yeah.
But I'm not seeing that.
if that were to happen next Saturday morning, I'll let you know.
That's good. Yeah, and the other thing was basically related to the difference opinion that they are, I wouldn't say absolute, but they are like at radical fronts where people think that 1 to a billion chance that we live in a simulation, whereas prominent scientists are saying, this is just pseudoscience.
Yeah. So I cannot speak for the opinion of others, but what I would encourage everyone to do is really be open about the possibility, because it's just a hypothesis right now. It's not a theory. It's a hypothesis that we make, and that's usually what we do in science. So you make a hypothesis, one, two, three hypotheses about a subject, and then you try to verify or refute it, and that you do by experiment and observation. And instead of doing that by experiment and observation, many people just have an opinion on it, and that's just how the world is. I have opinions on many things, but on the simulation hypothesis, because it would affect all humanity, because it would affect the universe. Of course, it's very tempting to make a statement right away,
Right.
except instead of making experiments. I don't know. So why people do that exactly? What do you think? What do you think is the reason behind just going out and saying that's what it is, or that's not what it is? I have no
I'm
idea.
having a huge challenge with opinions in general. We should do an episode on opinion, and when we talk in Germany about Meinung, right? I think there's an obligation to having an opinion about something, and I think it's too absolute today, from politics to views on geopolitical conflicts to quantum physics. Everyone has an opinion, and it's not an opinion in terms of I am seeking truth. It's an opinion where I'm postulating truth. And I think that's very unhealthy for society. So I totally agree with you with the openness. So we are built, it seems, a society that is postulating absolutes, and the whole philosophical contemplation of the search for wisdom is basically underlined that there is a will to truth, and if that is not given, then of course it's a challenge, right? And I'm just looking at some questions here. That was who's generated the simulation. I probably a 14-year-old girl sitting somewhere having a lot of access and saying, space time was a nice ride. You think there is something to that, Newtonian physics and Einstein and Mach and everyone. So it was a good ride, and now we have something else to play with. I don't know. And wer spricht Deutsch, Walter? Yeah, we all speak Deutsch. That's not an issue. But let me just before we move on to some wrap up question, if someone has some questions. I was just thinking about like this challenge of now creating the simulation just popped in my mind. So isn't it like today that 100 years ago there was like physicists creating theories, and then we started to build stuff on that? Isn't it so that with today's technology we start to simulate and build a lot of stuff? So when we have AI or quantum AI, we have these large language models, and we have all this technology, we start to build stuff that we don't really grasp. So isn't it so that like the whole essence of being a scientist today is also about first building and then understanding, or even expanding the understanding of nature? I think that, to me, that it looks like we're heading in that direction, like 100 years after the theoretical frameworks of quantum theory, quantum mechanics, whatever you want to call it. Isn't it like today we're building stuff first and then it's kind of sort of understanding how it works?
And it was you who reminded me about Richard Feynman's statement when you said to me, what I do not understand, I cannot create. But it is true sometimes that we do not fully understand the physics, and I'm talking only about physics now because that's just my field, of a system, but are still able to use it and implement things. So a good example is quantum physics. So when you look at the recent, or not the last one, but the previous Nobel Prize that was given for research on entanglement, it was not given for understanding what entanglement is, so this mysterious correlation between quantum particles. It was given for what it is not. And that's very interesting. So we still don't exactly know what it is, but we understand enough of it to build a computer and other systems. And that's truly remarkable. And when we build these systems and things, then we will understand and learn better.
So basically, coming back to your question, I mean, that's the essence of opinion. So a justified true belief or a validated plausible explanation of something always starts with an assumption, right? So there is what can we know about the universe always has an underlying assumption. It seems that postulating absolutes is a very difficult thing to do, especially about the conflicts and the challenges. But if you go all the way down to the very, very small, or the way up to the very, very big. It's always built around an assumption, isn't it?
Yes, and I would say it's a hypothesis in research. You make some hypothesis, and then based on that, that's the starting point. You make experiments, observations, and then you build and learn.
So we promised today we would do 30 minutes, our first talk, to play around a little bit. I think in the future we will do these talks and we will get into more specific concrete topics. We discussed about doing an episode in 2 or 3 weeks around potential products and services, business models of the future. So we'll get more into that nitty-gritty on what you are working on and what we think could be new business model for the future. But today we want to dig into the simulation hypothesis. And I mean, we tapped also a little bit around the new book that we have just finished, Singularity Paradox. I will also post a link to that if someone is curious. Yeah, Florian, how do we conclude this session? I mean, are people curious? Where can they look up stuff? Some things, some questions you can pop out there. How do we wrap our first quantum economy talk up?
Yeah. So I would encourage everyone really to think about, so in that case, the simulation hypothesis. So that was the topic for today. And move away from fixed opinions before going into depth and really reflecting on what would it mean and really reflecting on how could it be actually. So these are the encouraging words that I would want to leave everyone with. And also, thanks everyone for listening in. It was a great conversation.
Yeah, I mean, of course, there are some comments are coming in. We can take up the questions. I will just take the one that is an age-old question. Yeah, obviously, it's an age-old question. I mean, they were sitting there seeing the shadows on the wall, trying to explain what perception was. It's obviously that there might be limitations to what we perceive. Our sensory experiences are very limited. We know that. So will we be able to build all this that can expand this? Talk about, getting into other spheres of consciousness. There are many theories that would obviously blow this session out of proportion, but we could touch upon that in future. So yes, it's an age-old question, and also the whole challenge around the good and evil, God and evil. But the question from Hannah Hushler was, how would quantum computer facilitate simulation? Maybe you can touch upon that, Florian, before we.
Yes, absolutely. So when you look at the smallest compounds and components in our universe, it's the atoms, it's the molecules that stuff is made of. And these atoms, these molecules, they have quantum physical behavior. So they exhibit these quantum effects like superposition, like entanglement, that seem very crazy and unnatural as compared to our macroscopic world that we live in, because we don't observe them here in a macroscopic world. We don't see a chair, for example, existing in multiple configurations, like standing upright or falling backward. So these are things that we only observe on the quantum physical level. Now, a quantum computer can use these effects to do computations. So right now we use these effects to indirectly simulate nature, but at some point you can imagine a quantum computer or a quantum simulator in that case that exactly represents in its internal state the external system, an atom for an atom, so to say. And that will give me an exact simulation of nature. And I need to say one more thing about this. So that's also the problem when we think about simulating the universe, our universe, and that we are in, because that would mean if I would take all the 10 to the power of 82 or so particles of the universe and want to simulate them, then my quantum computer doing that must at least also consist of 10 to the power of 82 particles, actually many more, because that would only be the internal state. Therefore, it's impossible to exactly simulate the universe, because the computer would have, for us inside, because the computer would have to be bigger than the universe.
Yeah, I mean, I remember Florian when we talked to Marcus Flich about this, and he got very irritated because I said, it doesn't matter because I think the whole, we talked about in the beginning, the experience that we have, it feels real, it feels like something, and this is the fascinating part that get into this mixture. And I think whatever qualia on consciousness is, and we should do an episode on that also, it's basically that saying that if we take away that, and we would have some kind of entities in a simulation or computer game that wouldn't perceive anything. So the lights would be on, but there are no one home to perceive them. That would be a very sad world. And this is obviously what we have written about in Bridging AI and Humanity in the Singularity Paradox. And yeah, if you like these talks, we will get into some specific topics. We'll talk about business, future of economy, building a humane capitalism, how we think progress is the most important thing to tackle climate inequality, and how technology can be applied to do so with very specific use cases. Then just like the chats, like the channels, and follow us, and we will share information on the upcoming talks. If you like this talk, we will post a link below, so you'll get an update once we add the links to them. And yeah, thank you so much for watching, Florian. We have done our first quantum economy talk, and I think that 2 weeks from now we can get into some business use cases. We should do quantum goods and services next time, right?
Absolutely. Looking forward to it.
Looking forward to it. Have a great day and enjoy the San Francisco Bay Area. We have almost an evening here in Germany, so we have already taken care of the most chores. I'm off to play the piano and do some writing, and I wish you a great day, and thank you all for tuning in.
Thank you, everyone. Thanks, Anders.
Thank you.